Hi, my name is Matt Duff, and today we're going to talk about active versus passive filters. So if you've decided you want to do an analog filter, you basically got two choices, active or passive. Active filters just use an active element in the filter design, so like an op-amp, basically something that requires power. And passive filters don't require any elements that use power. So what are some advantages of active filters? Well, one nice thing about active filters is they give you low output impedance. So you can use the active filter to drive some stage later down the road here. And the reason that you have that low output impedance is because you're looking into the output of that amplifier. Another nice thing about active filters is that you can apply gain if you want. So because you're powering that extra element, you can actually boost the signal. So we can apply gain there. And then another nice thing about active filters is that they do not use inductors. So inductors tend to be kind of high tolerance type components. And also at lower frequencies, inductors are physically large. And so if you want to have a nice small filter design at the lower frequencies, having an active filter that only requires resistors and capacitors is nice. So that's some advantages of an active filter. When would you want to use a passive filter? Well, I'll give you three examples. So the first example is if you're trying to filter power. So typically you'll have a filter that looks something like this when you filter power. And you don't want to use an active filter with that because that active filter, that active element has to be supplied with some other power supply. And so you kind of defeat the purpose of passing the power through. So if you had something like a switching power supply, you typically hook it up here, and then this would get rid of the ripple but pass the power through. Another example is if you just need a cheap and dirty. So let's say we want a filter that only has 20 dB per decade of roll-off. Then just use a simple RC filter. Of course, these are all over the place in designs for precisely that reason, that they're so small and easy. So that's a very, very common passive filter. And then finally, if you're doing really high frequencies, so let's say above 10 megahertz or so. So above 10 megahertz, it gets really hard to do an active filter. And the reason for that is that the op-amp that you use in active filter design typically needs to be about 100 times more than the cutoff frequency of what you're trying to do. That really depends on the peaking and several other things, but kind of general rule of thumb, about 100 times. And so if we think about, say, a 10 megahertz filter, if you need an op-amp that's 100 times faster, that means you need a gigahertz op-amp. And they're really, you start to run out of choices when you're going that high. On the flip side, when you're doing a passive filter design, you can use inductors at those high frequencies, and those inductors tend to be nice and small. So let's say we do a filter design that looks something like this. So this is what's called a ladder filter, and it's a ladder filter because it looks sort of like a ladder, and you can keep adding stages here to increase the order, and it's typically used in higher frequency designs. So that's some pros and cons of active versus passive filters.